This video is for the Oregon State University Mastery Challenge for Electronic Test Tools. To begin, I'll be going over a demonstration of how to use a power supply. Alright, here we have the power supply on. We have it set to the amp selection. I don't have a load tested, but here you can see we have a current knob, and this is how you can adjust what current limit you want. And if I had a load adjusted, load attached, you could actually see the amperage change, and it would also affect the voltage. You can also change the voltage by using this knob. Alright, now I have the waveform generator here attached to an oscilloscope. You can adjust the amplitude of the signal using this amplitude knob. You can adjust the frequency using this frequency knob. And you can adjust the DC offset by taking it off its preset by pulling it out. And you can adjust it. Then go back to its preset, you can just push it back in. In order to properly calibrate your scope probe, you'll want to go into the menu by pressing the one button, pressing more, and then using the A dial to adjust the attenuation, which it has already been done. In order to view the waveform, you'll have to attach the scope probe to a signal generator or a circuit that has an alternating signal. We can also adjust what kind of signal we want using the function generator signal function, so we can have a square waveform, triangle, or a sinusoidal. To determine the voltage of the signal without looking or using the measurement function, you can look at the voltage per division scale, which you can see down here is set at 1 volt per division. You can change it using this knob. Changes. Each division is roughly one of these square grids, and so if we look at these, you have 1 volt, 2 volt, 3 volt, 4 volts, and about a half, so it's in between 6 volts, so it looks like it's about 5 volts. And if we look at the measurement function, you can see it's about 5 volts. In order to determine the frequency without using the measurement function, you use these two little knobs to adjust these cursors, and I've got them set to about the peak point for these two sections, which is just one period. And if you do the math, you can see here you've got the timing for B and A, and you can subtract those, and the frequency is equal to 1 over the period. And so if you do the math, as seen on my calculator, you get about 2.4 kilohertz, and looking at the measurement function, we have 2.4 kilohertz. To measure voltage, we want to put the digital multimeter to the voltage setting, have our common connected to common, and our positive lead connected to the voltage. Alright, here's my power supply. We'll be measuring voltage. You measure it in parallel, so across the circuit component. So you've got our positive and negatives connected in parallel, and you can see that it's measuring a voltage of 9.9 volts, which can be varied and changed. Alright, to measure current, you want to measure in series, so therefore you want to break the circuit. I've got a resistor here on a breadboard, so we've got the positive lead connected to the positive of the multimeter, and then the common ground goes out and then connects to the resistor on this side, and the negative of the battery comes to the other side. And so you can measure the current as 36.3 milliamps. To measure resistance, we attach 2 leads of the multimeter to both sides of the component of this resistor, and we can see that the resistance is about 3.2 kilo ohms.